Alright dudes, last video, what we're going to look at are a couple of inverse function graphs. Basically, we have some function that is graphed. They are both functions. They pass a vertical line test. We would just want to go graph their inverses. So let's remember a few things about inverses. I'm going to write a few facts here. Domains and ranges, they switch. So domains and ranges switch. What that means is for every point x, y that is on the original function, we're going to have a point y, x on the other function. And also another point of graphical significance is that the line y equals x, okay, y equals x. That is the line that has a slope of 1 and a y-intercept of 0. I'm just going to write y equals x. But basically that line right there, these inverse functions are going to be reflected about this line. So we're going to see these domains and ranges switch, points switch on the graph, and it's just going to be reflected about this. All I want to do is basically grab any significant points that I could see on the graph, and we'll label these. Like this is -3, 0. Okay, we get looks like -1, 2, and we also get 5, 3. So on our inverse function, I'll put it in a different color here. We would get not -3, 0, but 0, -3 would be right here. Also -1, 2. Okay, well that would be 2, -1 right here, and then we would say 5, 3. Well, that become 3 and then up 5, which would be on the top shelf here, and we would see that we go, oh, that was really straight. And we say, okay, how about here? So one thing that I want to kind of admit here is this. I would like to actually find the domain of the original, which I'm just going to call f, and I'm going to say the domain of the inverse function, which we say is in purple here, f inverse. So in terms of the domain, check it out. The domain of the original would be all x values from -3 and including -3 on to the right here. And so to write that interval, of course, we would just use bracket to include -3 and say out to infinity, but never including infinity. And also, when you look at the range of this function, it looks to me like it starts at a height of 0, or at least the lowest it goes is 0 here on the y-axis, and then it proceeds to increase forever and ever. And so we would go from a height of 0 on up and including 0. Here's my favorite thing about this. If you look at f inverse was in purple here, and its domain started at 0 and goes to the right forever and ever. So we would say that's 0 to infinity, including 0, but not infinity. That's our domain, just to be clear there. And then our range here, if we wanted to list it, we would say, well, the lowest it goes is -3, and then it increases forever and ever to the right of x equals 0. So we would say that this is -3 and including -3 up to infinity. Pretty cool. You see that these domains and ranges flat out switch. So let's do this again on number 38 here. Basically, let's label out these points. I suppose we see this as -2, 4. I suppose this is -1, 2. This is 0, 1. Let's flip them over, guys. So if I flip these over, we get 1, 0. We get 2, -1. And I would get 4, -2. Over 4 down to -2 here. Now this one's a little bit weirder to kind of decide what it would look like. So let's get in our line y equals x here, about which we're going to flip this. And still, this is kind of hard for me to determine what this looks like. So one thing that I do want to point out is, and it's not that we need to know this yet, is our first graph here seems to get really close to the x-axis but never touch it. And because inverse functions kind of do the opposite of one another, then this graph here is going to get really close to the y-axis here. It actually starts way up here and decreases just like the other one, but where this one flattens out, so does this one here, and so we get this reflected graph here, and we can label out all these just to verify it. But that's how you find an inverse graph. You just flip over your domains and ranges, and actually you could go find the domain and range of both of these, and you would observe that they are actually opposites of one another. As a matter of fact, really quickly, let's do that. Sorry to drag you on here, but f, looking at its domain, looks like it goes left and right forever and ever. So we had -infinity to infinity as our domain. As our range here, I won't belabor the point. Looks like the lowest we get is 0, but because of this horizontal asymptote that I'm telling you is there, we never actually reach a height of 0. And so we would say, starting just above 0 and going up forever and ever. Notice that I used a parenthesis here. So we would say on the interval from 0 up to infinity. Now let's look at f inverse here. When we look at its domain, it looks like it starts just on the right side of the y-axis here. So we would say starting at 0 but not including 0 and going to the right forever and ever. So we say 0 to infinity. I'm getting really bad at remembering to write the D here. And then we say R range. We would say it looks like that it is always increasing right here and always decreasing over here. So the entire y-axis is going to be hit by this function. Again, you can see domains and ranges switch. Cheers.